Hi, everyone, and welcome to Slooh's latest show. We're going to be talking about the very interesting 67P tonight. This is a comet where we've had a man-made lander land on this comet, which has been quite an incredible step for humanity. And it's had a bit of its pitfalls here, and which has been causing some, really interesting discussions in the scientific community. And one of them in particular being like, where exactly did it land? And we actually discovered that fact just a very short while ago, just this Sunday. Philae came online. We figured out where it is. And tonight we're going to be talking about what exactly that means for this mission and what it has meant in terms of having lost it and now having found it. There's a lot of very fascinating stuff happening tonight. And we're coming to you at sort of a unique time, a few hours later in the night than we normally bring these broadcasts to you. You can see this is a live view from the Canary Islands, and we're looking at a sky that is very, very close to dawn. We're very, very close to the day over in the Canary Islands. It's about 5 a.m. And really, it's because it's the only time we can see this comet is so close to the start of the day and the end of missions here at the Canary Islands. And so, really, without further ado, let me bring on our Slooh astronomer, Bob Berman, who's going to share with us this journey to this very distant comet from us and talk a little bit about really why we've had such a crazy adventure with this Philae lander. Welcome to the show, Bob. Thanks for joining me.
Well, thanks, Eric. It's great. We're in the wee hours of the morning in England, even in the sort of the wee hours of the morning where we are, but there is no time or day or night in space, so I guess it's appropriate. And it's a very exciting comet and a very exciting mission. Even though it's the Europeans, not NASA, not JPL, that did this, the European Space Agency. Still, wow, they pulled it off. What a coup. What a fabulous mission. And it's only going to get better because the comet's closest approach to the sun when all the stuff maximally happens, that's still coming up later this summer.
And really, we just got in a gorgeous first image coming in of the Comet 67P. We can see it right here live from the Canary Islands. And so you actually see a bit of comet-like features as we're seeing it, a little bit of a tail going out there. This
Yeah,
is
that's
the
so
place
cool.
that we have landed.
That's great. And we're seeing it live. We're watching it, we're hearing it on the radio and seeing it on TV, but there it is, live. There's the comet. It's going to reach its closest point to the sun, perihelion, on August 13th, just a night after the great Perseid meteor shower. So maybe we'll think of the comet while we're seeing those objects streak through the sky that are debris from comets. Meteor showers are all cometary debris. And let's remember this 67P comet. You and I both aren't using the long hyphenated Russian names of it. We're just copying out with 67P, but that's okay. That's because it was discovered back in 1969 by a pair of people from that part of the world using the Cyrillic alphabet and all of it. But it was chosen as the place to make our very first soft landing. It wound up not really being that soft because the retro rockets that were supposed to slow the descending Philae lander from the Rosetta spacecraft never fired. So the thing went bounce, landed pretty heavily. And then the harpoons that were supposed to shoot into the ice never fired. So the lander was not anchored. And then the screws turned that were supposed to screw the thing solidly into the ice, but they were just screwing into space, into vacuum. So that didn't do any good. So the thing leapt up into the air from the comet. Comet's kind of a small thing, only about 2.5 by 2.5 miles, and landed up in a place of complete darkness. You
And
might
yeah, here
wonder
we
how it
see.
could be complete darkness when the whole comet spins every 12.5 hours. There's day and night on the comet. So how could it possibly land anywhere so that the last 7 months have been in like a vampire's lair, complete darkness? But, every object has its axis and has a night side, and there are cliffs and shadows that are more or less permanent. So we had to wait all this time before sunlight still hit the solar panels and woke the mission up.
And we're seeing here where it landed and sort of just the chaotic path it has taken. There's a great number of media that came out of that exciting day when Philae was landing on this comet. Like here's its descent as it's falling away from Rosetta, the probe that took it to its final destination. And it's really we got so much uh, information in the first 60 hours when Philae just landed on that comet, and then all of a sudden everything just went very very dark. That we didn't get into contact with Philae until just about a day ago, and so it's been quite an adventure to see sort of where it's been going. Like why you were talking a little bit about it falling into darkness, and why was that such an important issue that happened with this comet, that it wasn't receiving sunlight, or the
Well,
lander?
because the energy source, unlike US probes, we use RTGs, which are radioisotope thermoelectric generators, which take plutonium and directly generate electricity from the heat given off from the plutonium. As we continue to look at a live, this is happening in real time, folks. This is right now, live image of this comet as seen from our Canary Islands facility here at Slooh. And so we use these sources of electricity, and had the Europeans used that, they would have generated 40 continuous watts of power. By continuous, it means just that. Day and night, doesn't need sun, doesn't need anything. 40 watts is plenty of power. But for mostly political reasons, a lot of people are anti-nuke, and it's their right to be. And we had this not so much with the early Mars missions, but especially with Galileo, and especially with the Cassini mission, which used 3 RTGs and something like almost 90 pounds of plutonium. And the fear was, what if there's a mishap at launch and this plutonium gets scattered? Plutonium can be deadly inhaled. And the answer is that the plutonium was in a form that really could not vaporize, and it was encased in iridium, which is soft and pliable, and that was further encased in a hard explosion-proof shell. So the scientists involved all thought it was quite safe, but nonetheless, they didn't use that, and that's why we've been relying on solar panels. And so when it's in permanent darkness, as this was for 7 months, no power and no images. But we're going to start to get images from the surface. And even without them, the Rosetta mission spacecraft, which has an orbit that changes its distance, but is always close enough to get really great close-up images. Yeah, we're looking at a live image of the comet, and now we're looking at, boy, this looks weird. Doesn't it appear like a neck? and a portrait like a bust, a shoulder, and then the head of an alien. It looks like an alien's head with eyes and a mouth and ears coming toward us. This looks like one of the weirdest, most sinister celestial objects ever. I don't know if you see it that way, Eric, or whether I've just seen too many sci-fi movies, but it's genuinely a weird object. Twin-lobed, started out at the Kuiper Belt, way past Pluto even, and slowly came inward. In fact, it had its orbit changed back in 1959. It was only discovered in 69, but we found that its orbit had been greatly altered by the presence of Jupiter. A close encounter with that giant planet changed its close point to the sun from the previous two, I think, 0.4, if I remember right, 2.4 Earth-Sun distances, astronomical distances, cut it in half to about 1.2 or 1.3 AUs. And that's nice because that's closer to the sun, it's brighter. And look what's happening here. You're seeing streams of, well, water vapor, because comets have ices. The ice can't melt because with no pressure, in the vacuum of space, it can only sublimate, so the ice turns directly to steam, to vapor. That's what you see streaming off, releasing embedded dust particles, and this is increasing its rate frantically. You know, back when it first landed, as we look at this live image, and we're seeing the material streaming out. That's what every comet's tail is. And we were losing about a gallon a second of water back then when Philae went to sleep. It's estimated that that's going to increase to 100 gallons per second very soon because at its close distance to the sun now, the activity is just going berserk. And that's why it's so much fun to have a spacecraft there and the Philae mission now alive and alert and showing us what's happening on the surface. Very cool stuff.
It's really just despite all the terror that happened with the harpoons and everything, the fact that all's well that ends well here is it's really great that we're actually going to be getting some actual scientific data from the surface of a comet. Do you have any thoughts in your mind, Bob, that you'd like to see come out of this mission? Any particular exciting discoveries that would just make your day?
Well, yeah, everything because comets, the two multiple objects in the solar system are asteroids and comets. Asteroids are rocky or metallic, and comets are mostly icy. But we've gone from thinking of them as dirty ices to kind of icy dirt balls. That maybe are more dust and gravel and pebbly, even though there's plenty of ice there. And so everything we learn is something new. And the weird shape, the nature of these comets. We get asteroids to hold in our hands because every one of the 50,000 meteorites that you see in museums or that you can even buy in meteor stores or online at meteorite websites, all of those are asteroid fragments, except for about 80 that came from the moon or Mars or the asteroid Vesta. They're all pieces of asteroids, not comets. We don't have any samples from comets because they're so flimsy between the little dusty particles and the ice. This can't survive a trip through the atmosphere. So when we see a shooting star, a meteor in the night sky, there'll be nothing left of it to reach the Earth if it's a comet fragment. So the only fragments that remain to become meteorites that we can hold in our hands are asteroids. So we're learning everything from this mission. It's just so exciting.
Really is. Dawn is coming, not the spacecraft, for the fun amount of science we're seeing on 67P. And I make that pun because we're just actually experiencing dawn in the Canary Islands, where the sky is lit up. It's officially the end of missions that we just came to, and we just went through that very end of the Slooh telescope's nightly journey on the Canary Islands with all of you, and it was a lot of fun to experience that. We're seeing that sun rise up. We saw that beautiful light gradient that came across the live imagery that you saw from the left. There was this sort of a brightness that filtered into the screen, and that was sort of our sunrise here that we were seeing in the Canary Islands. And as we move towards sort of the end of this uh, nightly broadcast here, there's a lot more that's coming up, of course, that we can always talk about. And there's two shows just tomorrow. So if you haven't gotten enough of Slooh shows yet. Don't worry, there's so much more to come. You scroll through the main page and you see it happening. We're going from comets to asteroids now. Our next show being the close approach of asteroid Icarus. It flew too close to the sun. Now it's flying a little bit too close to us, and so we'll see exactly what that means with some live views, again from the Canary Islands. And right after that, uh, let's go even further into our solar system here. With Jupiter's moons, we're reaching the end of the season of a fantastic slew of mutual events where there was lots of eclipsing and occulting of the moons going on in our view. In particular, tomorrow we're going to see Io eclipse Europa, and so we're going to see at one moon fall into another moon's shadow. So that's also a great show that's just coming up. And so, as we're leaving here with our thoughts with comets and exploring this solar system in just more vivid, uh, incredible detail than we've ever been able to do before. Any thoughts you have, sort of to lead us out, Bob?
Well, it's just great. We're doing this. That here it is live. Where everybody can pick up a newspaper and read about it, but how many people can look at the comet that's making the news live? So I'm just very proud to be doing that. Happy that we're bringing that to the public tonight, and look forward to tomorrow's shows. Let's get some sleep.
Oh yeah, absolutely. I mean, yeah. You said it so well yourself. That Slooh is all about the journey. We've shown you what it looks like looking at this 67p from telescopes on the ground, and then you see these incredible close-up pictures. What a journey Rosetta has made to get Philae to the surface of that comet, and there's just so much now that it's online that we have the potential to learn. So as science moves forward, look forward to what we're going to see next. You can't can't really predict it. It's going to be an exciting time. And so thank you so much, Slooh members, for watching. And let us know your opinions on this. Like, are you excited to see Philae online? Would you have liked to have seen a Philae with that had to do with some plutonium with an RTG device, that sort of deal? Is that something that you would have preferred? Like, let us know your opinions. There's a lot of places to talk about these shows, particularly the live show page. You are welcome to say your comments about what you thought here, as well as what you'd like to see in the future. If there's ever an object that is interesting to you in the night sky, let us know and maybe we'll cover it. But for now, there's a lot of shows coming up, so we hope you'll stay tuned. And this has been Eric and Bob for Slooh. We hope to see you again.